So another dynamic programming example that I'm not going to go so much detail within this video lecture is that DNA sequence matching. So this is more typical problem of introducing the dynamic programming rather than compared to the assembly line, but I took the assembly line as an example because that we are in the industrial engineering department, all right? So, okay. So DNA sequence matching, just giving you some context is that, so DNA is a sequence of the 4 letters, right? The C, G, G, A, T means that A, C, G, T are 4 letters that constitute of this DNA. When similar patterns are found, we suspect that pattern might yield some characteristics of the DNA owners. Means that if my daughter and I look alike, means that we are sharing some patterns within our DNAs, right? So that's our conjecture, and most times this is true, right? So hence, we need to find the patterns in long DNA sequences. So to analyze certain characteristics that someone exhibits, we might want to find out some patterns that matches to someone else. And how to find the match? How to find the match? How to find 2 DNA sequences and find the maximum longest common sequence, or LCS. Longest common sequence, right? How to find this? If we think about this word providence, we have PRIDEN, right? 6 letters match, the pattern matches. If we just dump this thing, right? ES, EV, T, and C, then this perfectly matches 6 letter matches, right? And here, the same, the matched sequence is the G, A, G, A, C, C, T, T, A, G, G, C, C. If we dump the all other characters, this is going to be the perfect match. 7 letters matches. How to find out these pattern matchings? Actually, the DNA sequence matching is a perfect example also the dynamic programming. So we have this, right, this memoization table setting, and this is the where they make things grow, right? Make things grow here, building up a bigger solution. I'm not going to explain this for you. Why don't you stop this video for a while and type this in and see how it works, okay? Okay, so let's find out the DNA sequence matching, how it works conceptually. So we have A and B sequence like this, and we added a blank here, right? And then what we are going to do is that because blank does not match to any other things, so we put all 0, and this is the memoization table, right? And actually what we are going to do is storing 2 values. So it means that we have 2 memoization tables, just like the assembly line case. We are going to store some cost, or the LCS cost. We have this LCS, and we are going to store some direction here. So how it works? What we are going to do is that if A and C does not match, then we are going to take the longest match here, and then put that value here and store where it is coming from. So 0 and 0 is the same, so it's either might come from the left or coming from the up, right here. We are going to choose just randomly to pick that is coming from the up to down. So, and then it's 0 to 0, right? And so rule is this: if we 2 characters, character 1 and character 2 does not match, then find the bigger LCS and store the direction. If it matches, then we are going to add plus 1 to the LCS, and we are going to make it diagonal. Okay, and I'm not going to explain why we are doing this thing, this problem, the parameter increase, but you will find out when you are filling out this table. So let's see how it works. So it doesn't match it to anything else. Doesn't match it to anything else. Doesn't match it to anything else. But at the time, C and C matches. So it means that it's coming to the diagonal, and by adding plus 1, it's coming from this diagonal. What does this mean? If we just limit to this problem A, G, A, C, and up to this point, C, then means that we are just matching this C sequence just one time, and up to this moment, the matches were LCS was 0, and this is what it represents, right? And the next thing is the C, right? And CC matches, right? And then what does this mean? Means that AG, AC, C, right? And then C, how it works, how it matches. Actually, it suggests that C matches just one length, because then we have only one C here, just one time matches, right? So it's still coming from 0 to plus 1 here. And of course, the rest of the matches would be all 1, because the C, we have only one C here. So that's what we have, all 1, right? And then if we increase this to the second sequence to CG, then let's see how it works. We have A up to this point, right? A and CG matches nothing, so it's 0. And if we increase the problem space to AG, it matches one thing, last to G and G. So up to this point, it matches 0. But when we are adding GG here, we have 1 plus match. So we put 1 here, right? And then let's make things grow up until here, right? Up until here, then we have, I'm going to erase it for space. Okay, so we have A, G, A, C, C, T, A, and we have what? A, C, and G, right? So how it matches up? So C matched where? C matched here, right? C matched here, and up to this point, the whole match was just one match, right? And then if we add G here, if we increase this sequence one line bigger, then we have another match found here. Means that we have 2 LCS. Means that we are going to add this 1 plus 1 to make things 2, right? Okay, so that's how it worked up to this point. Let's find out what to add here, right? We have up to this point we have A, G, A, C, C, T, A, G, A, right? And then we have C, G, G, A, C, right? and how it matches up. So actually it matched up like this, G and G, G and G, and A, right? And then if we make things grow one thing further in the upper sequence by adding C here, this C matches up. And then up to this point there was 3 matches, and by adding 1 plus, and we have 4 matches. So we are going to have 4, and it's coming from this diagonal. Okay? And then, of course, I'm going to erase it for you. The rest thing matches up, C and C, and then it's going to be 4. Of course, this was 4, right? And then we make things grow, fill in, right? And then we have C, and the C matches up, right? C matches up, so means that it's coming from the 7, right? And then C and C matches up, it coming from 7, right? And 7. So there is a whole 7 matches in this DNA sequence. LCS is going to be 7. And then what we are doing is the retracing this result, right? From this this sequence, right? This sequence show you where these matches come from. This item show you. Whenever we hit the diagonal, it means that there was a match, right? This upper or left, coming from up or coming from the left, means that there was this sequence in the rest of the sequence, right? So it is up or left, doesn't count, but whenever we hit diagonal, we can write it down. We hit diagonal here, so G and G match it up, right? We hit diagonal here, and here is G and G match it up, right? So we add G here, and then next thing is that this diagonal, right, is coming from this diagonal, and another diagonal, A and A matches up. So we put A here, and then it's actually T and T, this diagonal matches up. So T, right, and 3, and diagonal matches up. Here, C and C, right, and we add C here, and 2 add A, G, and we have 7 sequence of the match, right? So this is the further reading of this dynamic programming. So we have this kind of our go-to book. It's a very nice book introducing the algorithms, and we have this dynamic programming sections in this book. And why don't you go home and read this for a while? And it's actually it's just 30 page and 10 page. So it's just 40 page, and it's going to be a nice introduction for you to this dynamic programming. So just one thing that you have to remember is that in dynamic programming, we put the memoization table, and in the memoization table, we are storing small solutions and make things grow by utilizing these small solutions. And then when this memoization table reaches to the parameter set that we want to know, then that's the point to stop. And that's how we do that in the dynamic programming. I really just recommend you that you stop the video for a while and type in all these programs so that you really can know how it works, right? So this is the BOD lectures to the midterm, and the midterm will be midterm problems will come out from the week 1 to the week 6. Week 7 is just introduction about the simulation. It's not going to be in your scope, okay? Right, then have a good day.